Okay. Well, I want to start off with a question. Who here doesn't know what JRuby is? Awesome. Not one hand. We're not going to talk about what it is for very long, but we'll give the overview in case you missed some details. So I started this off and wanted to call it Ruby for the JVM. And really what it ends up being more is it's not just Ruby for the JVM. It ends up enabling a whole bunch of other stuff. So hopefully you'll get that by the end of the talk. Also wanted to kind of go into some discussion about how JRuby is put together so you can see the different bits and parts. Maybe see how you could contribute in particular areas and get a general idea of what JRuby looks like inside. And then we'll kind of talk about some use cases. So here's the quick agenda, a little background, internal design stuff. So a little bit more technical. If you like parsers, we have a little bit of that. If you like compilers, interpreters, we have a little bit of that. Got other stuff on threading, all that sort of nice little details. A couple quick use cases. We'll try and throw some little demos and code in here, there, and there. Here and there.
We aim to please.
We aim to please. So whatever you want to hear about, let us know, and we'll try and throw it all in. So I guess we've been called the JRuby guys fairly regularly now. I'm Charlie.
And I'm Thomas, or Tom.
And we've both been doing Java development for
more than a decade.
And we need to update this. It's more like 11 or 12 years now. But we're now at Sun Microsystems for about a year, a little over a year, working full-time to implement JRuby as well as possible. We also are helping on the various efforts to bring more languages to the JVM. Well, not really bring more, but improve the ones that are already there. There's like 100 and some language implementations that run on the JVM right now. And we've both done a lot of different development in the past, lots of different weird experiences. I actually didn't put my VB experience on there, so moving right along.
So JRuby is a Java implementation of the Ruby runtime, as everyone already knows. It was originally based on Ruby 1.6. Since then, we've updated it to 1.8. It was started back in 2002, actually before Charlie or I even got involved in the project. It was started by other folks.
Yeah, typical though most open source projects kind of just changed hands over the years, and we took over a couple of years ago.
Adopted it.
It's
under a few open source licenses, and we've had a lot of contributors. We thought we'd mention some of our other core committers, Ola Beanie, Nick Seeger, who's out here somewhere.
Wave your hand, Nick. There he is out in the middle.
That's him. Get him. Marcin Milzinski, which I'm not sure if that's the correct pronunciation, because I don't think neither one of us have ever met him in person.
No, I think only Ola's ever met him.
And Bill Dorich, another person we've never met in person, but we have heard his voice.
We've heard his voice. We have no idea who he is, but he's a committer. So I wanted to have one more thing here. Has anybody here submitted a bug or patch to JRuby? Raise your hand. Awesome. Applause for those people. Thank you. Because it's contributors like that actually have made JRuby what it is today. It's not any of us on the core team or any of the core committers. It's all of the community contributors that have really made it possible.
There's been hundreds of people that have just submitted one or two bugs and just scratched their itch. And
Yep. A little bit at a time.
So this can't be overstated enough that we want to be as compatible with Ruby 1.8 as we can, and when Ruby 2.0 comes out, we want to be as compatible with Ruby 2.0 as we can.
And Ruby 1.9. We'll start putting Ruby 1.9 features in very soon now.
It's a major guiding point. Now, with that said, the next point is we support native threading instead of green threading, which is not a compatibility it's a compatibility issue, but we find it a boon more than a bane.
There's various places where we've improved a little bit of the implementation underneath what Ruby 1.8 would be, just to fit better into the JVM or to provide some new options.
But we'll be talking a little bit about threading.
We'll talk a little bit about threading.
And we feel we have solid performance. A couple news items. 2 days ago, we released 1.02, which is an update on our stable 1.0 branch, and we fixed 99 bugs. Mm-hmm. So it's good. Yep. And even more exciting, last night, in fact, during Matz's questions, we released 1.1 beta 1, another conference-based release schedule. And in this particular branch, or our trunk now, we're focusing more on performance. So we were doing compatibility before, and now it's performance.
Yeah, we hit performance pretty hard over the summer. So there's JRuby starting to get around finally, and people are starting to use it and publish articles and books about it. Here's a recent cover from Java Expert, Japanese magazine, Java Expert number 2, and JRuby featured prominently on the cover here. Here also is Ola's book on practical JRuby on Rails, and recommend you check it out. He's got a lot more than just Rails stuff in there. There's a lot of JRuby details, how to get up and running, details on deployment, stuff like that. So it's a pretty good collection of books. And actually, Tim has an announcement here that he wanted to make very quickly. It's Tim Bray, also from Sun Microsystems.
I just wanted to make the point that we like Ruby even when it doesn't begin with a J. And so we're trying to do something about that. So there's going to be a press release sometime over the next couple of weeks. But the story is that we have just done a deal with the Graduate School of Information Science and Technology at University of Tokyo, where Sun and they are going to be working together on Ruby and primarily to look at the possibilities of multiple virtual machine implementations, which is, I think, real interesting in deploying web-facing applications, both in Ruby and JRuby and any other Ruby you want to think of. The lead there is a fellow named Professor Ikeo Takeuchi, who is famous. That's Takeuchi of the TAC function, for anybody who is a recursion weenie. And also one of the members of that group is Professor Koichi Sasada, well known to this crowd. And there's quite a substantial chunk of money going into that. And the bottom line is that when you pour resources and money into all of the different implementations of Ruby, that's just good for Ruby.
All right, thank you very much. Thank you. And again, to try and emphasize the fact that JRuby is not the only interest that we have in Ruby. We'd like to see the entire Ruby ecosystem do better across the board.
One other book thing, if you read Korean, there's a Korean JRuby book as well.
Yes, you may go out and get that one as well. I think that is actually officially the first JRuby book, another JRuby on Rails book. All right, so we'll jump into a little design overview of JRuby.
So we're going to go over some basics, parsers, core class, interpreter, and compiler. Everyone can read. Okay.
Right.
So the point of the slide is that the actual installation in JRuby looks a lot like regular CRuby. You have a bin directory. It has the same scripts you'd expect to be there. We have a few extras.
With a J in front, basically.
Yeah, we have some J's in there. JRuby C for ahead-of-time compilations, the script we have in there. We have some experimental stuff for doing client-server interactions. And then there's a lib directory, and it has the Ruby subdirectory you'd expect to find in a Ruby distribution. And there's a couple extra files, jar files that we have for dependencies, but basically it just looks like a regular Ruby distribution. And if you went and downloaded the binary distribution of JRuby, you just unpack it, set your path, and so long as you have the right version of Java installed, you're off to the races.
Which will run on pretty much, on a Mac, which I think there's a few here. It should just run out of the box, and most of you will have a Java 5 or 6 installation, and it just works after you unpack it.
I had to get a picture of all the Macs here so I can try to sell them to Apple. JRuby.jar contains everything you would need to actually run Ruby as a language, with one exception, the standard libraries, which are in that libruby directory, as I said before, except we have an option where you can have a JRuby complete jar, in which it even bundles those, meaning that it's no problem to actually load RB files from within a jar, and you can actually have this all in one single file, which is a distribution.
And this is actually a runnable jar with the entire standard library in it. So you could actually start this up and run IRB from one file.
So the Lexer, or scanner. It's a handwritten Lexer, and it's actually a port of the C implementation of Ruby. As I said before, it was originally based in 1.6, and then we tweaked it to work with 1.8, and now we've been hacking on it quite a bit lately, so it's not looking very much like the original port. But it's pretty easy to understand if you have the desire to look at Lexing code. The parser is basically Yak. It's a shift-reduce parser. It's called J. Again, our parser was a direct port of the C implementation. And we just run J on our .y file, and it generates a Java file. And great.
As far as I know, there are exactly 2 completely accurate parsers in the world. One is Ruby's and one is ours. Yes, knock on wood.
Yeah. The abstract syntax tree that we generate as a result of a parse is almost exactly the same as Ruby's, but we have like 1 extra node and we're missing 3 other nodes.
Some things juggled around.
So it's not exactly the same, but it's pretty close.
It's close enough that if you're using Parse Tree, which is the parse tree that runs on JRuby, it is able to massage the AST into basically the same structure as what the C implementation has.
It's nice as an implementation to actually have the freedom to choose what nodes you want to have versus, having that set for you.
Right, and we fully support not exposing the AST in any direct fashion. A standardized version maybe, but...
So one result of having a parser written in Java is that a lot of IDEs are actually written in Java. So pretty much every IDE now is adding Ruby support and using JRuby's parser. When people first approached us for this, the AST didn't have enough information to be useful for IDEs. So for example, we added offset. So if you have a symbol node, we'll record the start offset and the end offset so that an IDE knows that index 9 through 11 needs to be colored blue because it's a symbol.
So I'll jump over and do just a quick demo so you can see what this looks like. So this is NetBeans. And a lot of you probably heard that there's pretty good support in NetBeans for Ruby now. Here's a simple contrived class. And you get completion with documentation. All of this based purely on the JRuby parser. There's not actually anything running in Ruby behind the scenes. It's just using the parser to gather information about the code. And of course it narrows, and my little RDoc is in there as well. So we'll do that. We'll say hello RubyCon. Yes, I can. Okay. So RubyConf. Okay, and we've got our little method, and now some of the nicer features that this adds. This is pretty much just typical editor stuff, but Tor Norby, the guy who's actually working on this, has been able to add things like local variable renaming. And of course, we get variable highlighting in various places. It'll pick up constants that are being used in different parts of the code.
Unused variable detection.
Unused variable detection. So if I have x equals 1, actually here, if I just do x, see this is underlined. Now it's almost impossible to see on the screen, but it has a little underline that says it's unused. And now starting to get into more of the experimental features that will be coming up more in the future. You can see this is a big warning on the renaming of this method, since it cannot be done perfectly accurately. But we will rename hello to hello world, and it forces you to preview this. And if you can see this here at the bottom, you can see the changes it's going to make. The first one is that it's actually going to rename the method definition, and it will update the calls to it. So if we run this, you can see it renames the method. So just by having this parser, which is reasonably complete and written in Java, you're able to enable a lot of tooling like this. And thus ends the NetBeans marketing demo. All right, so back into the slides.
So all the core classes in JRuby are implemented in Java. There's a one-to-one correspondence between them. So if you wanted to look at the string implementation, for example, you'd go to ruby string.java, and everything would be there. For actually advertising or binding Ruby methods to the corresponding Java methods that implement them, we use Java 5 annotations. And here's actually the definition for the annotations that we use. So at the top, we have a list of names that are the Ruby names that would bind to the corresponding Java method. The number of required arguments you have, the number of optional requirements you have, whether it accepts REST arguments, and so forth.
So basically all the details that you might have about binding a particular piece of Java code in as a Ruby method can all be specified here, and then you don't have to do any of the wiring yourself. And it's all done at runtime.
And so there's an example down at the bottom of an annotation for a method called open with one required argument and some extra internal framing stuff that needs to happen for that particular method.
Okay, I'm going to jump over quick and just show really briefly. This is very similar to what John showed. We'll jump down here to some method. Okay, here's an example. Equal to equals method on the string class. Has one required argument, has the name, and the rest of it, is as straightforward Java code as we could possibly make it. But pretty easy for anybody to jump in and start making changes. And almost all of the almost all of the core classes are defined this way. So it's pretty simple for you to jump in and get involved with it.
And our apologies for not telling those who hate Java to avert their eyes.
Okay.
So our interpreter is a very, very simple design. We walk the AST tree by basically calling one method, which is a gigantic switch statement. Every case within that switch just represents one of the possible AST nodes. And each node does its stuff and maybe recursively calls that same switch-based method again, or maybe just loops back up to the top. Probably 15 or 20 minutes, and everyone here would understand how our interpreter works.
Yeah, pretty simple. It's similar to Ruby's eval.c, but cleaned up a little bit.
So for the most part, everything starts out as interpreted because there's a cost to compiling stuff. If you're only going to run something once or twice, you're not going to want to have that cost associated with it. But there are a few exceptions. Command line scripts do compile right away. If it's obviously pre-compiled, there'd be no reason to interpret it when you can just load the pre-compiled stuff. Evals are something that most of the time you would never want to compile, though we're starting to find use cases where it'd be quite compelling. But as of now, we interpret all the time for evals. And as I said, straightforward code.
It actually gives us a lot of flexibility, the fact that we have an interpreter. We don't have to, for example, in JRuby 1.0, we had part of the compiler done. It was maybe 25% complete, something like that. But we were able to enable it. So once there were methods it could compile, it would do so. But it would still fall back on the interpreter for the pieces that it couldn't compile yet. Now with JRuby 1.0, or 1.1, we have a full compiler to Java bytecode as part of the release. And it was in the 1.1 beta release. There's only one bug I know of, and only I know about it, so I'm not going to tell you what it is.
A T-shirt to anyone who can find it.
Yeah, a T-shirt to anyone who can find it. At this point, the compiler is basically done. And we're pretty proud of this fact. This is the only complete 1.8 compiler in existence. It is the only compiler for any version of Ruby to a general-purpose VM. So it took a bit of work, but we managed to get there. It actually does emit standard Java bytecode. It's not really a Java class that you get out of it. It's more of a class that's sort of a bag of methods, and then those methods get bound into their appropriate places at runtime. In general, you can either use this in an ahead time mode, where you compile it down to a class file, and then you've got your entire app pre-compiled, or you can just run the code and it'll eventually JIT while it's running. It'll run interpreted for a while, and the hottest methods will eventually compile down to bytecode and start running faster. And here is I'll just show you this. This is more interesting in live demonstration.
That's big.
So, here we've got a very simple benchmark for wonderful Fibonacci, nothing too fancy. And let's see how big it is. One side effect of compiling to bytecode is that it is a bit bigger than the original source. So we'll JRuby see this, bench recursive. And this will start up and compile it to a class file. And ls dash. I'll show you the difference in size here. A little bigger. Not a whole lot we can do about that, really. It's just that bytecode ends up embedding a lot more information than you have in the source, because there's a lot of keys and things. So if we want to actually run this, all we have to do is, obviously I have some basic Java configuration set up here, and we'll run it. Oh, we'll require bench. Oh, yep, okay. So let's grab that quick. Yes, definitely. Oh, that big. Okay. Okay, so that gives you enough. I will grab this file real quick. And give that another shot. And, here we go.
So notice that he compiled the fib code, but the benchmark code is still running interpreted.
Right, benchmark code is still just a .rb file. And if I actually run this with the server VM, which ends up doing a lot more deep optimizations, you'll see that there is a significant improvement in the performance. And I think 186 runs this in about 1.7 seconds per iteration, and 1.9 is something like 0.45, something around there. So that, simple demo. And of course, if I just run this directly, bench recursive, we'll do server as well. You'll see that this is actually going to be the same numbers, roughly the same numbers, because it is just doing the compilation at runtime for you. Okay, back to the slides. All right. So now the compiler really is ready, and you can use it. Generally, you want to choose ahead-of-time compilation mode if you want to avoid the JIT warm-up. So if you have an application that has a lot of different files that it requires, they're not going to compile immediately. If you want them to be compiled already when the application starts, you can do ahead-of-time compilation. And hopefully in the future, that will also result in faster startup time for your application.
In theory, it should use less memory as well, right?
Yes, one of the biggest memory hogs is the AST and all the symbols that are stored there. So the precompiled version should use a little bit less memory. But if you just want to run your code like normal Ruby, you can just let it fall back on JIT mode, and stuff will eventually compile anyway, and you'll eventually get the same performance. There'll just be a little bit of a warm-up time for it. So really, you don't have to do anything different in that case. So now some of the performance optimizations. I wanted to talk through some of these. I'm not going to get too deep into these because some of them are a little unusual, a little weird. The first one, obviously, is compiling. By compiling a script, you end up getting considerably better performance because it's just that much easier for the JVM to optimize it. And you saw in the earlier example, it was even more of a difference between the two. So this is the first one is interpreted, pure interpreted. It's not doing any compilation. Runs about 2.5 or so, and then considerably faster once you actually compile it down or let the compiler run. There are a number of different optimizations that are actually in the compiler. First off, all literals can be pre-allocated when the script loads so that they don't have to be constructed every time. We've got a number of places where we actually use Java's own opcodes, Java's own bytecodes for local flow control. So for example, in regular Ruby 186, where an explicit return is slower than letting it fall off the end of the method, in JRuby that's not the case. A return is exactly the same as falling off the end of a method. They're both just a Java return operation. Similarly, for next and break, they're just branching operations, and they're just as fast as a Java branching operation. We also try to use Java local variables whenever possible. Generally, this means methods that don't have evals in them, that don't have closures in them, or closures themselves that don't have evals or closures contained within them. And this allows us to avoid a lot of overhead of allocating a space for local variables on every call. It basically becomes almost as lightweight as a normal Java method because it is just using regular local variables. Now, the inline method caching. Does anybody know what an inline method cache is? There's a few. There's Evan.
Evan knows.
And I know Koichi knows what an inline method cache is. So we have an inline method cache right now that definitely helps Java optimize. Inline method cache essentially is a little tiny cache at each call, everywhere you have one in the code, and on the first time you call a method, it will save that little method object in that spot, so it doesn't have to go do the lookup again. Now, it may have to kill that cache if it turns out that you're calling with a different type or if the methods have changed, but in general, this allows almost all code to eventually have a direct path into the target method. No more method lookup cost at that point. Adding the inline method cache actually brought the fib benchmark from about 1.2 seconds to what you saw before, about 0.6. So it was a huge improvement. And right now it's a monomorphic inline cache, which means that if you have a single call that ends up hitting multiple methods, it will keep refreshing itself, and it'll never actually cache. 4.1.1 final maybe will have a polymorphic cache, which will allow it to cache multiple methods at that site, if it actually shows some benefit. It only shows it on very specific benchmarks right now. So optimization number 2, and this is the one that's a little bit more controversial. I don't know if anybody saw the thread I started on Ruby Talk to kind of discuss this. Ruby has this feature called object space. Does everybody know what object space is, roughly? Pretty much. Object space, one of the features is this each object method, which lets you iterate over all objects in the system. You pass it a type and a block, and it will pass each object of that type to you in turn. Now, this is easy to do in Ruby because it has all of those objects available. It's only running one native operating system thread at a time. So it can say, hey, I'll stop everything, and I'll walk those objects for you, and you can do what you want to do with them. Unfortunately, on JRuby, where we have fully concurrent threads, we have a very complicated advanced garbage collector in the JVM, we can't directly access those objects. So we have had to save a reference to every object that's created during execution, which sucks. I mean, it's painful. That means at least 2 additional Java objects for every Ruby object that you create. Not to mention they have to be weak references, so the objects can still be collected, and that slows down garbage collection in general.
So it sucks 2 to 5 times as much.
It sucks 2 to 5 times as much as running normal code. And the sad thing about it is that it's practically never used. The only real-world case where a lot of folks see each object getting hit is in test unit, where it uses it to find all test cases. This is how test unit actually works. If you have a file that just has a test case class in it, there's no actual code at the bottom to run it, right? But if you execute that class, it will start it up, and it'll run the test. Well, it does that by going and looking for all test case classes. Yes, Ryan?
I think of a lot of other real-world cases, like all the memory debuggers and profilers that we have written out there.
Yes, which would be entirely applicable, but only to Ruby objects as far as JRuby is concerned, and only to Ruby objects as far as regular Ruby is concerned. It's not going to pick up C memory issues either. So it's only for a particular narrow range of things. And again, this is not a production time issue. We still support object space in JRuby.
Yeah, that's the important part.
That's the important part. We're turning this off only for general execution. If you want to turn it on, there's a flag you pass. Also, and each object will work. We've also hacked it so that each object for class, which is what test unit uses, will continue to work, basically by keeping a weak hash of classes to subclasses. Yeah, another question here?
Yeah, about this. It seems like this is kind of a big change to make. Just for performance issues, should we just default to each object being enabled and disabled if you need to better performance?
That's what we did, and we had a disable flag for it. The problem was that no one ever remembered to pass that flag and then kept telling us, why are you so slow? And the fact is that almost nobody will ever see that this isn't enabled. Yeah, the question that we had was, why would we turn this off by default? Why wouldn't we leave it on and allow people to turn it off on their own?
Basically, we got so many more questions about why is this not running as fast as it's advertised that it became more reasonable to actually turn it off by default.
Right. It ends up crippling performance for 1% of cases. And I'm going to continue on, and we'll come back to some questions towards the end here. So that's one. I'd love to debate with anybody that wants to talk about it, because it is still there. It's just not going to be there for normal execution and production code if you don't enable it. So one of the third optimizations that we've got is we've got a number of custom core classes. The simple way to implement string or array would just be to use existing classes in Java, and that's what it was. We used existing string buffer for a mutable string buffer, and we used an array list for array, and it turned out that that was a lot slower than just having our own custom implementations. So this guy, Marcin Mielzinski, Lopex on the channel there, he ended up implementing an entirely new copy-on-write string, a new copy-on-write array implementation. He re-implemented hash. He re-implemented a number of the numeric types, and he's been doing more since then. We've also got these custom regular expression implementations. So we've been through a number of different regular expression libraries. The first one was just to use Java's existing regular expressions, which worked really fast. It's probably the fastest one that we've ever used, but the design caused it to blow up for larger alternations, larger input. And, for example, if you want to parse large HTTP requests, Rails does that with a regular expression.
It didn't work well with CGI.RB.
Did not work well because it would just eventually blow up the stack. So we switched to JRegex, which was a little faster. Unfortunately, it's character-based rather than byte-based. So for every matching operation, we have to switch from bytes back to characters, and then characters back to bytes. Terribly slow, adds a lot of overhead. So Ola actually went ahead and ported the Ruby, the C implementation's regular expression engine, to Java. This is now a little bit faster than JRegex in cases. It's got a few problems where it's 5 to 10 times slower that we're trying to resolve, but it just uses bytes directly. And it's exactly compatible with Ruby's regular expressions. So that is probably the one that we're going to ship with 1.1 just because of the compatibility and speed issues. And then Marson, has anybody heard of Oniguruma? Yes, Oniguruma is the gigantic, amazing new regular expression library that's going to be in Ruby 1.9. And Marson said, hey, I can port that. And recently he said, I shouldn't have said I could port that, but he's continuing to work on it. And he says that he can have it done for 1.1. So this would be an encoding agnostic, byte-based, high-performance regular expression engine for us that would allow us to have full compatibility and all the performance that we're looking for.
He's 3 weeks in.
He's about 3 or 4 weeks into the implementation. He says he can have it done by December.
And he says it's going to grow the size of JRuby by about 20 to 25%. So it's a big project.
The guy's a machine. He's a machine. So threading. We mentioned that threads are actually fully concurrent in JRuby. That was really more the easy way to go. We could have implemented green threads, but it would have been a real hassle. And since Java's threads are already native, we just kind of did it that way. And it ends up allowing a lot more parallelism. You run a lot of applications in the same JVM, and they won't step on each other. We do also still emulate all of the unsafe thread operations. Like thread kill and thread raise, these are inherently and provably unsafe operations. We support them basically by checking in once in a while to see, am I dead? Am I dead yet? Am I dead yet? Adds a little bit of overhead, but at least it allows us to emulate the features. We also implement critical similar way. Again, critical is impossible to guarantee in any sort of real threading environment. Another unsafe operation that we just kind of emulate as best we can. And these are unsafe in regular Ruby as well, just in case you didn't realize that. So the last bit here, to try and avoid the overhead of spinning up an operating system thread every time you start a Ruby thread, we have a thread pool. This is not complete right now. It should be for 1.1. But this basically makes spinning up a JRuby thread almost as fast as spinning up one of Ruby's green threads, as long as there's threads available in the pool. So hopefully that'll be done for 1.1 as well. So another question that comes up about JRuby is, do you support C extensions? I've got all these C extensions I want to use from Ruby. And the short answer is no. We do not support running regular Ruby C extensions, largely because the Ruby API exposes a little bit too much for us to emulate. For example, you can go in and manipulate string structures directly and string bytes directly if you want to from an extension. And some extensions do. And there's other cases where it goes and accesses other memory structures. So it's a little difficult for us to emulate that even through JNI or JNA, any of the C-based connections for Java. So we do not support those right now. However, most of the time those libraries are used to hook up to a native library like ImageMagick, for example. And we are shipping with this library called JNA. It's not JNI. It is basically a DL-like library for Java. It lets you go in and call arbitrary C libraries and link them in and call functions that are available in them. So you could use this very easily to pull in any of those libraries. In general, we encourage people to use what the Java platform has available. There's a number of image processing APIs and libraries in Java already. So there's really not a good reason to go out to the C libraries. But if you really have to, you can do it through this. We're also using JNA to implement POSIX functions that aren't provided in the Java platform, like, for example, chmod. We had to emulate for a long time. Get UID and a bunch of the other ones that are not platform independent.
One other thing is that all the major native extensions that you would need to use for Rails, for example, have largely already been ported to Java. So
right.
Might not
with
be
the
a practical problem.
with the exception of RMagic, although there's plenty of other image processing libraries in Java, there is an RMagic JR or something.
RMagic Junior.
RMagic Junior. I think it's JRuby, but it sounds like Junior. And that is a port of the RMagic library that uses Java image processing under the covers. And it's partially done. It's not complete yet. But apricot works, and there's active record JDBC stuff.
If anyone's really interested in image processing, the person who supports ImageMagick JR said he's not going to have a lot of time to work on it. So it'd be a great project to get started in.
Yeah, that would be a big help. So one of the last areas here is the fact that you can call into regular Java code. And generally, we just present these. Java types look like Ruby types, and Java objects look like Ruby objects. And you just call methods on them. You can have the camel case or the underscore case. They both work. And then being able to integrate with the actual type hierarchy. You can implement Java interfaces. You can extend Java classes. And really, it all just looks like Ruby code. So there's really not too much to this. So here's an example of calling into Ruby from Java code. Nobody really cares. Here's an example of calling Java code from Ruby. And, other than the top couple lines there that actually pull in Java support, it really pretty much just looks like Ruby. And of course,
yes.
all the array methods are available for you on collection types, iterations available. All the basic things that you would expect from these things are available.
Is there time for the live demo? I think.
Yeah, I think that's coming up here pretty quick. So one of the popular use cases for the Swing for Java integration is to build GUIs with Swing. Swing is Java's platform-independent GUI library. It's very large and very complicated, which makes Ruby a perfect solution here to simplify it. And Java is also kind of just too verbose. Ruby makes it a lot nicer to look at and actually makes Swing development fun. The other half of this is that there's not really a great cross-platform GUI library for Ruby. There's a number that mostly work, and there's a number that are cross-platform but don't look great. But there's nothing that's really consistent and runs across all platforms and is easy to set up everywhere and all of that. There's also no really fire and forget execution. You can just have a single Ruby script, JRuby, execute it, and there's no change that you would have to make for any platform. You could really have one file that's just JRuby and your application, and it'll run everywhere. It'll just work. So that's definitely a big benefit. And there's a couple different ways that you might do this, just to give you some examples of how you might wire in Swing, for example. There's the direct approach, where you just pull in the components directly, call the methods on them directly. We've got some shortcuts for adding action listeners and other event model handling. And then you show your frame. Now, how many of you have seen the quick Swing demo that I tend to do at these talks? There's a couple, so I think we'll go ahead and do it. It's fast, and we're doing pretty good on time.
I've seen it 100 times. I never get sick of it.
So actually, maybe I'll just do this in NetBeans here. So one other nice thing that we have in NetBeans, a community member contributed this Swing-based IRB shell. Oh, and that's going to be too small. I'll just do it in the other one. So we've got our little IRB. This is actually just regular IRB with a J in front of it. So, but include Java, import Java X Swing JFrame. Okay, some nice nasty logging output there. Frame equals JFrame.new. Hello. Okay. Oh, what was that?
Uh-oh.
Uh-oh. That's what I get for running on trunk. Offset exceeds bounds. Wow.
What version of Java are you using? This works flawlessly. We swear.
Yeah, well. Let's see if it actually works. Yeah. Okay. Let's see if we can actually show it. If it doesn't work. Oh, there it is. It did work. It's just noisy. That's all. All right. And I got the 10-minute notice, so there. It works. But yeah, I mean, you can. Huzzah. Here, I'll do this. Frame.set size. Wow. It's actually live. Okay, so bye. Swing demo. Okay, so back to this. Now there's a couple other ones that I'll just blow through here. This is more of a builder approach. It's the Cherry library. And this is kind of a nice DSL-based swing library. Profligacy, which is Zed Shaw's project for doing swing development. It takes a little bit less of a builder approach. You really still have all the same components here. You have your JButton, text field, label, etc. And the magic is that you have this new little layout language. It says translate's going to be left aligned, input's going to be centered, and result's going to be right aligned. So a nice simple way to do direct calls and direct layout of your swing components. Monkeybars is a more recent entry. It basically decided to be GUI editor friendly because pretty much anybody who wants to build any non-trivial app is going to use a GUI editor. Here's the example in NetBeans of what the editor looks like. But it lets you then wire it in with a controller. Using that existing GUI that you've built, you can just attach a bunch of Ruby code to it and basically have a working application. So web applications are the other big domain that people have been using Ruby for. And obviously the Rails is probably the largest right now, although some other ones are coming up. And really that is the primary option that people are doing for web development with JRuby on Rails. It's been working in JRuby for almost a year now. If you count our 2006 Java 1, where it was hacked miserably to sort of work.
It worked.
It was work. Oh, you like to claim it worked. It worked well enough. Worked well enough for demos, which is all that matters, right? So that was really more like a year and a half ago. But, I mean, it works. It runs great. And there's actually a lot of production applications that are going up now with JRuby on Rails instead. It uses JDBC, Java's JDBC, to connect up to the database. So there's this little active record JDBC connector. Really all you do is install that, and there's not much more you have to do. It handles all of the driver details for you, or at least it will when Nick releases the next version. And then you have Rails running in Java using JDBC, hooking up any of the databases that it supports. Pretty simple. There's also these two little tools, Goldspike and Warbler, that allow you to deploy Rails into a typical Java application server. And if I can actually get that to work quickly, we'll go over here and so this is all just running JRuby again, and I'm not going to do anything interesting with this app.
Again, deploying as a WAR file might seem unsexy, but if you want to go and get a job at a place that has a Java application server already installed, you just generate the WAR file, put it there. They don't have to learn how to go and support Mongrel or anything else.
So Warbler gives you this command, warble, which basically just pulls in a bunch of the dependencies. It unpacks Rails. It's got some rake stuff, active support. And it pulls in all the dependencies, all the libraries that you might need to run this as a standalone app, and then builds a WAR file. And then that's actually just an app server independent WAR file. You can deploy it to Tomcat, Glassfish, whatever you want. It works anywhere. There is also a somewhat nicer way to do this that's a little bit more Rails friendly. Glassfish Rails is a gem that you can install that is an entire application server in about 3 or 4 meg gem. Gives you this command, and it starts up.
And this is a preview release of this.
Right, this is a preview release. This will be coming along, but now with this one command, this is deploying the application that I pointed at. Started up in about 7 seconds. This is a production server right now. And this is all you would need to deploy a JRuby on Rails app in production with basically the same performance that you would get on C Ruby and better in some cases. And that's it. There's no monet. There's no multiple Mongrel processes. This is the one process that you'd ever have to have. So I think this is going to be a huge benefit of running JRuby on Rails. And we're getting a little close to the end here. So we've also got a thing called Active Hibernate, which is coming along. It allows you to use a different persistence API. Hibernate basically looks like regular active record. Option number 2 is Tom's Rootlets, which are going to be coming along in 1.1. Basically just gives you a servlet-like API for purely implementing servlets in Ruby. And you can end up deploying it to an application server.
It's not a real logo.
So here's an example of bare bones one. Here's more of a servlet-like. really this is very similar to camping, the way it structures stuff, so that you can have your gets and posts.
If you're interested, just come up and talk to me. This is still a work in progress, so it'd be nice to get some input.
Right. This is going to be in 1.1. Now, the last area that people seem to be using JRuby for is test and behavior-driven development. And so one example would be using test unit. And this is actually testing a Java class here, the server socket class. The other half of this would be behavior-driven, where you can start writing specs for Java code. And actually, I don't really test out most Java libraries in Java anymore. I end up using JRuby and one of these libraries, or just writing code directly to call it.
So much less code.
It's so much less code, and it's a hell of a lot easier. So we'll close it out here. I mean, you can see the takeaways here. I think you kind of get the point of this. JRuby is ready for just about anything you want to do. Anything you can do in Ruby, or anything you do with Java, you can do both in JRuby, and it's ready for you to start doing stuff. We'd love to talk more with you about it. So we're going to be here the rest of the weekend, and feel free to come up and talk to us. Thank you. Take one or two. All right, we'll take a couple really quick questions. Yes, in the back, Francis.
Hey, Charles. Okay, on the object space thing, I don't like object space much either, and I think in the long term you could make the case that we should actually be making the Ruby core language smaller to make life easier for JRuby ironruby Rubinians.
Right.
But I do think, I mean, just my opinion, and I hope you don't think I'm bike shedding, but I do think right now, for better or worse, it's part of the core. So may I humbly suggest that what we do to deal with object space is have it be in there by default, put the flag in to take it out when you're running it, and then every single place you document JRuby, how to download it, how to run it, just say, use this flag, and have a thing in your FAQ. Why is it so slow? It's because you got to use this flag. And have a page. What's the deal with object space? Just explaining the thing. That would be my recommendation.
All right. Excellent. Next.
Noted.
Noted. Yes. Right here. Sure. Oh, you want to see that real quick, and then we'll call it done, and you can come up and talk to us anytime. All right. So here, it's in the same directory. So this is with regular Ruby. Okay. Cursive RB. This is with Ruby 1.8.6. Oh, it's a little slower than I thought. 1.7.5, 1.7.6 or so. And just to be totally honest about it, we will actually run it quick with Ruby 1.9. I'm not sure if this is totally up to date, but it's close. Ruby lib. And I know. Okay. And there is Koichi's amazing Yard, which runs at 12.4.
Look at it go.
Yes. All right. And we will catch him. But and we won't have time for any more questions, but please come up and talk to us. We'd love to talk about anything that's on your mind, especially if it's about JRuby. So thank you very much.